Hi YouTube and welcome back to my channel. So in this question we're going to be evaluating the definite integral where our integral goes from natural log 2 to 0 of this expression. Meanwhile, we have already solved a question like this earlier and I'll be adding a link to it in the description below. So to solve a question like this, just like we did the first time, you start by taking out the constant, and the constant here is 2, so you can quickly take that out. So you have 2 natural log 2 0 cos x dx. So the next thing we do is to rewrite cos x in its exponential form, and that means we can wipe this and replace it with its equivalent is e raised to the power x plus e raised to the power minus x, everything all over 2 dx. Now if you look carefully, you would see that this alternate form has denominator as 2. That means you can say half times this numerator, so that means half is a constant too. So just as we did for the first step, we can remove this half. So to remove it, we simply just clear this and we have over 2 here, which we cancel, and then we have 1. So now you can open up this bracket by multiplying this by everything here. So you remember your exponential rules. If this multiplies this, because they have the same base, you have e raised to the power minus x plus x, where this will give you 0. So you have e raised to the power 0, and anything raised to the power 0 is 1. So this would give us natural log 2 to 0, 1. Now e raised to the power minus x times e raised to the power minus x. So this would be, let me quickly wipe that. So here we would have e raised to the power minus x, which is e raised to the power minus 2x. So for this part, we would have plus e raised to the power minus 2x, everything dx. So because these are two different terms, we can integrate them individually. The integral of a constant, in this case 1, is x. So this would be x for the first term. Then for the second term, the integral of this dx. This is the same thing as saying the integral of e raised to the power u if we say u is minus 2x. So it means that du is minus 2 dx, and this also means that du over minus 2 is equals dx. So in this case, instead of the x, now we have the u over minus 2. So du over minus 2. And the integral, let me wipe this. The integral of this, first off, you can start by taking out the constant, which would be minus 1 over 2. But the integral of exponent of u is still exponent of u. So that does it. Where are u? We said that u is minus 2x. So we can wipe this u and replace it with minus 2x. So the integral of this term is this. So we have plus e raised to the power minus 2x all over minus 2. So we can as well just say, take away this plus, take away this minus, replace this with minus. Now we are moving from natural log of 2 to 0. Let's quickly wipe this. So this is what we have to resolve this expression from natural log of 2 to 0. So where our x is natural log of 2, we have natural log of 2 minus e raised to power minus 2 natural log of 2 all over 2 minus x is 0 minus e raised to power minus 2, 0. So this is the expression we have at this point. So for this expression at this point, natural log of 2 minus exponent minus 2 natural log of 2, and we have this where if we can start by opening this bracket, so that would leave us with, I think I should just wipe this, minus 0 minus times minus, that is plus this, so we can as well just wipe out this part. So this is what we have. So we can start from here. Minus 2 times 0 is 0. Anything raised to power 0 is 1. So let's quickly rewrite this. You have, this is 0. Anything raised to power 0 is 1. So it means this whole expression, let me move it a little bit. So it means this whole expression would be 1 over 2 plus. So coming to this expression, we have exponent of minus 2 natural log of 2. So this can be rewritten. Exponents would usually cancel the natural log. So when this cancels out, this is the same thing as saying 2 raised to power minus 2 all over 2. I hope this is clear. Let me do it again. So for this one, this part, I'm just going to rewrite it till we get what the answer is supposed to be. You have exponent raised to power minus 2 natural log of 2, and this expression, this numerator, can be rewritten. This is also the same thing as saying, let's remove this, raised to power minus 2. So exponent and natural log cancels out, and what you have here is 2 raised to power minus 2. I hope this is clear. So that's how we have 2 raised to power minus 2 all over the denominator 2. Then we are left with natural log of 2 minus this. So we can still resolve this more, because 2 raised to power minus 2 is the same thing as 1 over 4. And 1 over 4 divided by 2 is the same thing as 1 over 8. So I think I'll just rewrite this in the next page. So I have natural log of 2 minus 2 raised to power minus 2 over 2 plus 1 over 2. So I just said that this, I'm just going to write it, natural log of 2. This is the same thing as saying 1 over 2 raised to power minus 2 is the same thing as saying 1 over 2 raised to power 2, which is the same thing as 1 over 4. Now when you have divided by 2, this is divided by 2 divided by 2, which is the same thing as 1 over 2, right? So that gives us 1 over 8. So this expression gives us 1 over 8. Let's wipe up a little bit. So I have 1 over 8 minus 1 over 8 plus 1 over 2. And when you add this minus 1 over 8 plus 1 over 2, we are going to have plus 3 over 8. We can do that by the side. We have minus 1 over 8 plus 1 over 2. Common factor is 8. 8 divided by 8, 1 times minus 1 plus 4. So you have 4 minus 1, that's 3 over 8. So that's how we have 3 over 8 here. So this is an answer. This now is an answer. So we have this as a solution. I hope you liked this video. If you did, tap on the like button and tap on the subscription button too, and I'll see you on the next video. Thank you.